Hi, I'm Cheryl Leach. In this video, we're going to look at a problem where we need to find the equation of a tangent line to the graph of a function at a given point. So what do we need to do? We need to find the equation of a line. To get the equation of a line, we need two things, the slope of the line and a point on that line. But this is not just any line, it's the tangent line. And we know that we can find the slope of a tangent line by taking the derivative. So that's how we're going to begin. So to find the slope, we're going to find f prime of x. Now let's take a look at our function. It's fairly complicated. We've got a cubing function, a squaring function, constant multiples, subtraction, addition, and even a power of 2 at the end. So we need to begin with the outside operation, the one that encompasses the entire function. And in this case, it's that squaring function. So we're going to start with the general power rule. So we'll bring the 2 down, copy over that entire expression that's in parentheses. So x cubed minus 2x squared minus x plus 1, and then subtract 1 from the exponent. But now we need to take the derivative of that inside piece because we need to use the chain rule. So what is the derivative of that inside function? Well, this is just going to be 3x squared minus 4x minus 1 and plus 0. So altogether, 2 times the quantity x cubed minus 2x squared minus x plus 1 times the quantity 3x squared minus 4x minus 1. So this is going to be the slope at any point along my curve. I'm interested in what happens at the point 1, 1. So at the point 1, 1, my slope is going to be 2 times the quantity 1 cubed, which is just 1, minus 2 times 1, that's going to be a 2, minus 1 plus 1. And then I need to multiply that by 3 times 1 squared, that will be a 3, minus 4 times 1, so minus 4, and minus 1. So in each of the parentheses, I'm going to have a 1, minus 2, which is a negative 1, minus 1, which is negative 2, plus 1, so that'll be a negative 1. And then I have a 3 minus 4, which is a negative 1, minus 1, and that leaves me with negative 2. I now have 2 times negative 1 times negative 2 for a grand total of 4. So the slope of my tangent line is 4. The second thing I needed to get the equation of that line was the point. This was given to me, so that's easy, 1, 1. Now I need to put these two pieces together to get the equation of the tangent line. So I'm going to use my point slope formula. Y minus y1 equals m times the quantity x minus x1. And now I need to substitute in the appropriate information. So y minus 1 is going to equal 4 times the quantity x minus 1. With a little bit of algebra, I'll distribute the 4 across and make that 4x minus 4, and then add 1 to both sides. So I have y equals 4x minus 3. And this is the equation of my tangent line. Now let's use a graphing utility to help me visualize my result. I'm going to begin by entering both my function and the equation of the tangent line into my calculator. So I'll begin by carefully entering this expression, making sure that I use parentheses so that I square the entire cubic piece. So I've got parentheses, x cubed minus 2x squared minus x plus 1. Close my parentheses and then be sure to square that. Then I'm going to enter the equation of my line, 4x minus 3. And graph it. Now, if you're using a standard window, you can see both the function and the tangent line, but it's very small. So you may want to play around with the window a little bit. If you change the window so that your x minimum is -2, your x maximum is 5, and you have a scale of 1, and change the y minimum to -2, the y maximum to 5, and the scale to 1, you can see the graph much clearer. And this particular window, it was just arbitrary. You can try playing with different windows, but something that zooms in a little further seems to work best. I hope this helps. Thanks.